In this integral, we see a number of related functions, sine and cosine in particular, that might give us some guidelines as to substitutions that would help simplify it. Again, we note at first there is no obvious antiderivative of this function, so we resort to one of the integration techniques. Now, there's only about 3 options that I can see in terms of building a substitution for this integral here. Starting at the top, we could choose sine of x, we could choose the entire denominator, or we could choose the cosine alone in the denominator. And our job is to either try each of these and see what happens, and that's perfectly fine, it just might be time consuming. Ideally, though, we'd like to try to reason through which one of these would work best. And again, if we refer back to what the substitution is going to do for us, we're going to divide by dw dx. As part of our process in the substitution, when we replace the dx part, we effectively divide by dw dx. Well, if I choose sine and I divide by cos in the end, that's not going to make life easier. If I think of what the derivative of this term is, it'll be 0 plus 2 cos x sine x. I don't want to divide by cos x sine x, so I'll get some cancellations, but I'll still have more cosines in the denominator. However, if we choose cosine, then I'll get to divide by its derivative, which is sine, and then I'll cancel the sines out, and I might get a simpler integral. So that kind of logic is how I would at least try to get a first guess. It might not always be right, but it'll be a good first guess as to what an effective substitution is. With that chain of logic in mind, let's let w equal cos of x. As soon as we do that, we know that its derivative is negative sine of x, or rearranging this, we have 1 over negative 1 over sine x dw equals dx. So we've got our dx replacement and we've got our cosine replaced. That means that our integral of sine of x over 1 plus cos squared of x dx is equal to the integral. The sine, we don't have any replacement for it yet. The 1 plus cos squared, we said that cosine was w, so we'll have 1 over w squared. And then the dx part, we replace with dw and the 1 over sine stuff. That's our dx. And now we see the benefit of this choice of substitution. We cancel, and we get negative the integral 1 over 1 plus w squared dw. And we double check, is this simpler? Yes. Does it have no x's? Yes. And most importantly, not only is it simpler, we know the antiderivative of this. If you look through your catalog, 1 over 1 plus x squared. 1 over 1 plus x squared should remind you of arctan. The derivative of arctan is 1 over 1 plus x squared. In this case, it's w's, so it's arctan of w. And then plus a constant for the general antiderivative. And then we just go back to x's. Arctan of w was cos of x. And we can leave it at that for now. There are fancier ways to simplify it, but this will do for today.